Dear learner, today we discuss a topic. Before that, I had sent a video of hybridizations. After that, so many students told me that, sir, please send such type of video which create interest in organic chemistry as well as analytical chemistry. So to get a complete update, dear student, you can subscribe in YouTube. Then you will get a continuous update of organic chemistry as well as analytical chemistry. So before starting this video, we must have to know about hybridizations. If we know about the hybridizations, then we can do something for aromaticity. Let us start. What is a aromaticity chart and all these things? So here I can say in simple way, PHC. In case of right now in lockdown period, this is primary health center. But in case of our molecule must be a planar. Molecule should follow the Huckel rules and molecule should be a cyclic conjugations. Now the first question, how to decide a planar? We have to check whether the hybridization is sp2 or not. Sp is not possible because it has a 180-degree bond angle. How to check Huckel rules, that I will explain you. Cycle, you can easily identify if the compound is cyclic, then it is possible. Let us see the chart for the aromaticity. So the chart is, for the flow chart is, first step is to find out the hybridizations. Let us go ahead. After finding the hybridizations, there are two possibilities. One, all carbon have sp2 and sp3, either sp2 or sp3. Then carbon have sp2 hybridization. We can say only sp2 hybridizations. So let us go ahead. In case of only sp2 hybridizations, there are two possibilities. The possibility number one, a number of pi electron. After finding these hybridizations, we have to move the pi electron. Pi electrons means a lone pair and negative charge, which we have included in our hybridization chart also. Here this number of electron is 4n plus 2 pi electron. This is Huckel rules. And here the electron is 4n plus pi. 4n pi. So if this electron is 4n plus 2 pi electron, then we can say this compound is aromatic and we are very happy. If the electron is 4n pi, then we can say this compound is anti-aromatic and the compound have one of the hybridization is sp3, then we can say a number of pi electron according to 4n plus pi electron. This is not required at all. Then there is no need to check it also. Is it? There is no need to check it also. Then we can say this compound is non-aromatic. Just I have kept that to understand this concept. This electron is whatever in case of non-aromatic. Let us move ahead and we will check for I have told you that I will explain you the Huckel rules. For the Huckel rule, there are 4n plus 2 pi electron to being aromatic and 4n pi electron to being a anti-aromatic. Anti-aromatic. Let us keep the value of n is equal to 0, 1, 2, 3. If we keep 0, then the pi electron is 2 pi electron. N is not anything, a ring or everything. This is a natural number. If we keep n is equal to 1, then we are getting 6 pi electron. If we keep n is equal to 2, we are getting a 10 pi electron. If we are getting a 3, then we are getting a 14 pi electrons. Okay, so if this electron is 2, 6, 10 and 14, we can say in a change of 4, 4, then this is a aromatic. Now in case of here, n is equal to 1, 0 is not possible, there is no pi electron, it is a non-aromatic. 2 and 3. So if we keep n is equal to 1, then what we are getting? We are getting a 4 pi electron. If we are keeping n is equal to 2, then we are getting 8 pi electron. If we are getting 3, then we are getting a 12 pi electron. Is it? This all about little bit theoretical point of view. Now we goes to the exact example. So that also we have seen. Now let us we move to the a 3-member ring system. We will see one by one. First 3-member, then 4-member, then 5-member. According to our chart, first we have to decide these hybridizations. Let us, we have seen our hybridizations video also. So we can say this is sp3 hybridizations. This is sp2 hybridizations. This is sp2 hybridizations. Oh, according to that chart, we can say that this have a sp2 and sp3 hybridization. If this compound has sp2 or sp3 hybridizations, then we can say this compound is what? It is a non-aromatic. Is it? Now let us see another example here in a side. So to check it, we have to see these hybridizations. First is this is sp2 hybridizations. Again this is sp2 hybridizations. Again this is sp2 hybridizations. All are sp2. Then we have to check what types of pi electron. Here a pi electron is 2 plus 2. Here is 2 plus 2. 2 from this and another 2 is from this. So total electron is 4. All are in sp2, so it is in under hybridization, under cyclizations, and 4 electrons are comes under according to this. According to this, we can say that 4 electrons are come in this case. So it is come in this case. It is known as what? Anti-aromatic. So dear student, according to this example, we come here. This is the example of anti-aromatic. Let us see this next example. Here we check the hybridization first. During the checking of hybridizations, we found that this is sp2. Again this is sp2. Again this is sp2. According to that chart, if all carbon has sp2, our next target is we have to find pi electrons. So they have a, how many pi electrons are there? There are only 2 pi electron. If it is 2 pi electron, then we have to check where it is come. Then we can say if it has 2 pi electron, it comes under this. If it comes under this, then we can say this compound is an aromatic. Is it? So this compound is what? This is one type of aromatic compound. We can say it comes under this category. So let us see. This is known as what compound? This is a aromatic compound. This is the possibility in a 3-member ring structure. Let us go ahead and 4-member rings. So in case of 4-member rings, here also again we will check this hybridization. So this is sp2. This is also sp2. This is also sp2. This is also sp2. Let us see. After getting all, it has how many pi electron? It has a 2 pi electron. If it has 2 pi electron, we can say this compound is aromatic. Because according to 4n plus 2 pi electron, that comes under this. Let us check for this. This is sp2. If you don't know hybridizations, please see my first video. sp2. This is sp3. This is sp3. So according to that chart, if it is come under sp2 and sp3, then we can say it is a non-aromatic compound. There is no required to calculate a pi electron. Let us come here. This is sp2. This is also sp2, this is also sp2, this is also sp2. Dear student, if you don't know hybridizations, don't go in organic chemistry, then you can got the does not get anything. From here we are getting 2 pi electron, from here we are getting 2 pi electrons, from here we are getting 2 pi electrons, total is 6 pi electrons. So we can say it's come under, let us see once again, it comes under the 6 pi electrons, it comes under where, it comes under a aromatic ring system. So this is what this we have seen, and this is known as a non-aromatic. Then this has a 6 pi electrons, so it is known as an aromatic compound. Let us check this. This is sp2, this is also sp2, this is also sp2, but dear student, this is sp3. So according to this chart, let us go back, let us go back, oh sorry, let us go back, and here if this compound has one of the sp2 carbons is there, this is sp2 carbon is there, then we can say it is a non-aromatic compound. So according to this, this is our non-aromatic compound. We can also make so many example. If we want to draw, here I have given some representative example, most probably, but it is covered. So if I want to make a draw the one structure, then I can also draw such a structure, and this is one of the best example of 4-member ring, which is has a sp2, sp2, sp2. This is also sp2, and it has a 4 pi electron. So this is what, this is a anti-aromatic. This is possibility. Another, this is most important, the most important, because why it is most important, among here whatever the example I have given to you, one of the example which is uncharged anti-aromatic compound at room temperature is a cyclobutadiene. This is, we can also take this example, and dear student, you think on it, and what you get the answer you can write in a YouTube in my chat box, so I can understand that up to what extent you are getting in your mind. So I hope you see this video and give the answer of this compound in my comment box of a YouTube. Let us see. Thank you for watching this, and if you like this, share it, and to get a continuous entertainment and enjoyment in learning sessions, you may subscribe this so you continuously get a video for analytical and organic chemistry. Thank you.